Regents Review number 29. In this question, you're asked to find the 11th term of this sequence. The first thing you need to do is to look at the pattern in this list of numbers to determine if it's arithmetic or geometric. Sometimes the pattern can be hard to determine. So this is the math that allows you to choose between arithmetic and geometric. You're looking for a constant pattern of either a difference or of a ratio. So you go to the second term and then you subtract the first term. Or you go to the third term and you subtract the previous term. And each time you do this, you should result in the same value. If it's geometric, then when you go to the second term and divide it by the previous term, you should get the same ratio. Right? So this is how you check. So let's take a look at what we've got. We've got 3, and then -6, and then 12, and then 24. If I was to use my calculator to check this pattern, like I showed you here, I would take -6, and I would subtract 3. Press enter, I get a -9. Now I'm going to do it again with the third term. So 12 subtract -6. And you see how I have different values? And if you have different values, that means it does not have a constant difference. So now I'm going to check the pattern for geometric sequence. Take the second value, -6, and divide it by 3. Take the third value, 12, and divide it by -6. You'll notice I'm getting the same result here, so the common ratio is -2. That makes this a geometric sequence. And if we know it is a geometric sequence, then we need to know the common ratio, which we discovered was -2. The next thing you could do is look on your reference sheet at the geometric sequence formula and fill in the appropriate values. So the geometric sequence formula is that the answer for any position is the answer in the first position times the common ratio raised to the n-1 power. You're going to erase and replace the answer in the first position and the common ratio that you have to determine on your own. Now it tells us that we want to find the 11th term in the sequence, so that is going to erase and replace the letter n. Remember, this over here is just the narrator. It's not any part of the math that we need to solve. So the answer in the 11th position is equal to 3 times the quantity -2 raised to the 11th minus 1 power. Pick up your calculator and begin to type those characters as you see them. $3,072. Look carefully. Choose the correct sign, and don't get tricked. Number 2, which situation represents exponential growth? So exponential growth looks like this, or it could even be a geometric sequence that looks like this. But in both situations, it is a timesing formula, something that is multiplying. So if you're adding $10 to a jar each week, that's not exponential. If you grow 105 feet per year, you're adding 1.5 feet every year. Ella earns $20 per hour babysitting. So that's plus 20, plus 20, plus 20. The number of people majoring in computer science doubles every 5 years. So that's times 2, times 2, times 2. So that is exponential growth. Number 3. This equation is used to find the velocity of an object as given as v squared equals u squared plus 2as, where u is the initial velocity and v is the final velocity. The good news is you don't even have to understand what this problem is talking about as long as you know what the question is. When the equation is solved for a, that's it. You don't need to know that it's about velocity and acceleration and all those things. you want to isolate the letter A. So let's begin here by copying the question and remembering to focus on the letter A. So this would be the last thing we really want to attack. We kind of want to get rid of this term that is being added to it. So we're going to subtract u squared from both sides. Because these are unlike terms, we write them side by side. Alright. 2 is multiplying A, and S is also multiplying A. So to remove that, or undo it, we're going to use an inverse operation of dividing. And we're going to divide everybody on every side. You can divide by two things at the same time. And that leaves us with A is equal to V squared minus U squared over 2S. Question number 4. What is the equation of the line that passes through the point 6, negative 3, and has a slope of negative 4/3? Well, we're talking about a point and a slope. And if you look at your reference sheet, there is an equation, I'm going to scroll down here, called the linear equation point-slope. This can be used to help you solve this problem. The point-slope equation is y minus y1 equals slope times x minus x1, and now all we need to do is erase and replace. The slope is negative 4/3. The y value over here is negative 3, so that goes in the y1 spot. Careful, there's two negatives here, right? So let's simplify this equation to see what we've got. Y plus 3 equals negative 4/3 times x, and then negative 4/3 times 6, which is going to be a positive 8. I'm going to subtract 3 from both sides, and that leaves me with y is equal to negative 4/3 x plus 5. Again, this doesn't look like any of my answer choices, but that's because none of my answer choices have an isolated y value. In order to isolate each of these options, I simply divide each side by 3 here, or for this one, divide each side by negative 3. And I would do that for every choice. So when I look at choice number 1, when I divide by 3, I get y is equal to negative 4/3 x plus 5. But when I do it for option number 3, I get y equals negative 4/3 x minus 5. So you notice the difference? We found our answer. Question number 5 asks you to graph the equation 3y plus 2x equals 15 on the axes below. In order to graph an equation or an inequality, you need to write it in slope-intercept form. So I'm going to start by subtracting 2x from both sides, rewriting the equation. In any order, I could put the 15 first, or I can put the negative 2x first. Then I'm going to divide every term by 3, resulting in the final equation of y is equal to negative 2/3 x plus 5. Now you can graph using this intercept and slope number, or if you're uncomfortable with that technique, you can use your graphing calculator to type the values into the y equals button. Once the equation is in slope-intercept form, you can type it into this y equals button here by entering negative and then alpha y equals for the fraction key, negative 2/3 x plus 5. Now, you can look at the graph by pressing the graph button to give you an idea of what your final result should look like, but you shouldn't be grabbing any points or trying to estimate any points from here. You simply press second graph to get to the table feature. And once you're there, you may find some fractional values, so you're going to want to scroll up and down until you find some of these perfect integer points like 0.5 or negative 3.7, etc. If you're graphing using the slope-intercept technique, you start at the y-intercept, which for us is 5. So you draw your first point at 5, and then you follow the rise and run of the slope. And because there is one negative sign, you can only give it to one of these numbers. And it doesn't matter if you give it to the numerator or the denominator. If I gave it to the numerator, I would be moving from this initial point at 5, -2 down, +3 right. -2 down, +3 right. -2 down, +3 right. And that would draw this lower piece of my line. But if I gave the negative to the 3, then I would be traveling up 2 and left 3. And I draw as many points as I can to extend that line all the way to the edges of the grid. Once I'm done, I label my line. And now I answer this follow-up question. Explain why -6, 9 is a solution to the equation. Well, there's two ways you can prove this. You can prove it mathematically, or you can prove it visually. So let's take a look at the graph. If they asked me to explain using the graph, then I would go to the point -6, +9, and I would see that it is actually located on the graph. So that is one thing you could state. -6, +9 is a solution because it lies on the graph of the line. That's one possible answer. It doesn't say that you have to state your answer based on the graph, so if it did, that would be our only response. This is called based on the graph. How do I know based on the graph? Because the point is on the line. It doesn't say that, so if I would like, I could write my equation this way, and I could erase and replace, right? I could erase and replace my y and x values with the x and y values they gave me. They said x is -6 and y is 9, and I can prove that 9 is equal to, that would be 12 divided by 3, 4 plus 5, that 9 is equal to 9. This is called a justification. Unfortunately, justification is not an explanation. So you can't just write math. If it says explain, you have to have some English. So you could say, when substituted into the equation, the point -6, 9 satisfies the equation. Or you could say, it makes the sentence true, something like that. But you can't just show math if it says explain. Question number 6. Determine the common difference of the arithmetic sequence in which A1 is equal to 5. Oops, that's a little too big. And A5 is equal to 17. They told us it's arithmetic. They told us it's a common difference. So we're trying to decide, what do we need to add or subtract in order to make these moves to get to 17? Well, I can clearly see that I'm getting larger. So if this is increasing, then that means I am adding something each time. I'm adding something once, twice, 3, 4 times. I'm adding something 4 times. Now, what do I need to add 4 times to make a jump of 12? Right? To get from here to there, that's an increase of 12. So if I have to split it up into 4 jumps, that must mean that I'm adding 3 each time. So my common difference is 3, increasing by 3. Right? So D is equal to +3. Now determine the 21st term of this sequence. So I have to state the common difference. So I did. I answered the first question. Now I'm going to answer the second question. I'm going to go back to my reference sheet. I'm going to grab that arithmetic sequence formula right here. And I'm going to copy it onto my workspace. A sub n equals a sub 1 plus d times n minus 1. I'm going to erase and replace, or write underneath here, that the answer in the 21st position is the first number, then the common difference, which is positive 3, and then 21 minus 1. Pick up your calculator, go to the main math screen here, so quit out of this, and I'm going to type 5 plus 3 parentheses 21 minus 1. So it looks like the 21st term, the answer in the 21st position, is going to be 65. And that's how you answer question 6. Number 7. The formula D equals T times the quantity V sub I plus V sub F divided by 2 is used to calculate the distance D covered by an object in a given period of time. Nobody cares what the problem is talking about, just find the question. Solve for V sub F. That's the one we want alone. So when I copy my question, D is equal to T times the quantity VI plus VF divided by 2. Then the first thing I need to do is get rid of anything outside of these parentheses. So I'm going to divide both sides by 2, giving me D divided by T is equal to the quantity VI plus VF divided by 2. Now I remove the parentheses because there was nothing to distribute anymore. So now what I'm going to do is remove the denominator by multiplying both sides by 2. Now be careful over here. When you multiply a fraction times a whole number, you only multiply the numerator, like this. And now I can get, remember what the goal is, V sub F all by itself. I'm going to do that by subtracting V sub I from both sides. And since I can't combine these terms, I put the fraction first, I put the minus VI second, and the V sub F on the other side. Question number 8 asks you which point is a solution to x cubed minus 2x. Now you can try a guess and check strategy here. And by guessing and checking, you take a value and you substitute it into the equation and see if the answer is negative 21. Or you could use your TI-84. And when we use our TI-84, we go to the y equals button and we type in our equation. So I'm going to type in x cubed minus 2x. So that's x raised up to the third power, arrow out of the exponent area, and subtract 2x. Now I could look at the graph if I want. I'm going to see a pretty curvy graph here. And I can try and decide, but this graph only goes up to 10. So I wouldn't be able to see if 21 was a number. So I'm going to look at all of the solutions by checking out the table. And once I get into the table, I see negative 3 is in fact paired with negative 21. Negative 2 is not paired with 10. Positive 1 is not paired with positive 1, right? So I'm looking at these answer choices and I'm seeing how they relate to the table I've seen in my calculator. So it looks like this one is the solution because it is the only point that falls on this graph. Question number 9 asks you to find the value of x. So we're going to solve this equation by first subtracting 9 from both sides, leaving me with this large term over here on the left and a 5 on the right. Now you can't do any math with the numerator until you have cleared the denominator. So I'm going to multiply both sides by 3, giving me 5 times the quantity 2x minus 4 equals 15. Now you have two choices for this next move. You can either distribute the 5 and make everybody bigger, or you can divide by 5 and make everybody smaller. That leaves us with 2x minus 4 equals 3. I removed the parentheses because there's nothing left to distribute anymore. So I'm going to remove this one here. We don't need it. And now we're going to add 4 to both sides. 2x equals 7. We're going to divide both sides by 2. And that's our final answer, 7/2. If you're not sure what that is, you turn your calculator on, you quit out of any function you're using, and you simply type 7 divided by 2, and you can get your answer. So 3.5. It doesn't hurt to check it on a calculator. Question number 10. This one contains a box plot, and it's asking you which number of these choices is the third quartile. Remember, a box plot is constructed from those 4 quartile numbers: Q0, Q1, Q2, Q3, and Q4. These 5 dots are how a box plot are created. And it always starts with 0 and ends with 4 because it's a quartile. So the third quartile is the far right side of the box. So we found our answer at 60. All right, the last question asks you to find the solution to this inequality. So I'm going to distribute this -3 first, giving me -3x plus 18 is greater than 2x minus 2. I'm going to choose to subtract 2x from both sides because all of the answer choices have an x on the left. So if I move my x to the left, it will be easiest to match it to an answer choice. So -5x plus 18 is greater than -2. Subtract 18 from both sides. -5x is greater than -20. And when I divide both sides by -5, this causes a reverse order to my inequality. So x, and instead of a greater than, we're going to flip it to less than. So x is less than 4.